How do exponents relate to fractal geometry? Have you ever looked at a snowflake and wondered how something so beautiful can have such complex patterns? The answer lies in the fascinating connection between exponents and fractal geometry. Let's break this down in a fun and easy way. Exponents are a key part of mathematics. They tell us how many times to multiply a number by itself. For instance, to raise to the power of 3 means 2 times 2 times 2, which equals 8. This simple concept becomes much more exciting when we look at fractals. Fractals are shapes that repeat their patterns at smaller and smaller scales. This self-similarity is where exponents come into play. When we talk about fractals, we often use fractional or non-integer exponents. This means that instead of just whole numbers, we can describe the complexity of fractals with numbers that are not whole. For example, if you double the size of a fractal, its detail might increase by a factor of to raise to the power of a fractional exponent. This fractional exponent is known as the fractal dimension. It helps us understand how the detail of a fractal changes as we zoom in or out. Unlike regular shapes, where doubling the size multiplies area or volume by whole numbers, fractals can behave in unexpected ways. When we create fractals, we often do this in steps or iterations. Each time we repeat the process, we apply a scaling factor that is raised to an exponent. This means that the number of smaller, self-similar pieces grows exponentially with each step. At the same time, the size of each piece shrinks exponentially. This relationship between scaling and iteration is a key feature of fractals. In more advanced studies, exponents also show up in scaling laws that describe how fractals behave in different situations. For instance, they can help us understand how certain properties of fractals change during critical points in physical systems. This connection between exponents and fractals is not just theoretical, it has real-world applications. In fields like computer graphics, understanding how exponents work in fractals allows artists and designers to create stunning natural landscapes and textures. By applying scaling rules governed by exponents, they can generate images that look incredibly lifelike. Additionally, exponents help us analyze complex networks and natural phenomena that display fractal-like patterns. By quantifying their behavior with exponents, we can better understand how they function. In essence, exponents are the mathematical language that describes how fractals scale and repeat at different sizes. They help us quantify fractal dimensions, express self-similarity, and model the growth of fractal complexity through iterative processes. This connection reveals a whole new world of numbers and shapes that exist both in mathematics and in nature.